Last week I was in Delhi, and in my 8 years of as a regulator, I have attended perhaps 10,000 conferences, and this is the best. That conference in Delhi was the best I have attended. You know why? There's a scientist who was explaining quantum mechanics, and one of the property of quantum particles is called entanglement. And the way she explained, and if you are a vivid Bollywood follower, in Bollywood we have a typical story that a twin is born to a mother, poor lady. She goes to a village fair, and the twins get separated, and one becomes a dacoit, other becomes a police officer. After many years, they meet together, look identical. They found a way to connect to each other, and that is called entanglement. That's how I understood quantum physics. So that's the level of explanation I want from both of you when you explain AI and Web3. So very simple, easy to understand. Web3 is a very complex topic. Every time I read, I get confused. So, Joichi, explain this very complex topic in the most simplified way so that we all understand and don't ask this question, Web3, what is this all about?
Okay, I'll try. So the internet was very important because it allowed many things to interoperate on a communications layer. So we had all of the networks became one, and you could send email to anyone, and the protocol was set up so that you could read, because in the old days before internet, your email from your company couldn't go somewhere else. If you opened a file on a Macintosh, you couldn't open it on a Windows machine. So that interoperability for communications was at the core. But the problem, the missing link was there was no way to send money or promises or do transactions across the system. So I think the major thing that Web3 is allowing us to do is to, in an open protocol way, in a public way, securely make promises, do transactions, and write things in a immutable way. And I think that this is all a larger trend to switch from paper to digital, right? So I think right now, if you look at a company or a government, you're just a bundle of accounts and contracts, right? So you make a lot of promises and the lawyers turn them into contracts, and you move things around and the accountants turn them into accounts, and those accounts are held by banks, they're regulated by regulators, and so on and so forth. But it's all paper. It's humans, lawyers and accountants writing on paper your promises and your accounts. And it's all filed on paper, and all of the analysis and work is done by hand. What we can do once it's all digital, and this is what the blockchain will do, is it will secure all of our contracts, all of our accounts. It will allow us to programmatically manage corporations and governments in our accounts. And if you think, 7,000 years ago, we had clay tablets with Sumerian cuneiform in Mesopotamia. And that allowed us to scale cities to over 10,000 people because we could keep track of all the stuff. But it's very centralized. And then about 600 to 700 years ago, we had double-entry bookkeeping and moved from technology of clay, which is very difficult, to paper. And then we got double-entry bookkeeping, and we had probability and statistics. And so we were able to create corporations and decentralization. We have modern capitalism and modern democracy. And the people in Mesopotamia couldn't imagine our society today. But it was all, I would say, a shift from clay to paper, and from centralized ledger to double-entry bookkeeping. And now what's going to happen is, as we move to blockchain, we can now manage much more complex things. And instead of human beings writing the accounts and writing the law, we can do this digitally. And I think the key thing, and this is, I think, the topic for today, is that, but without AI, we can't manage that complexity, and we can't control it, and we can't understand it. So I think what's going to happen now is you're going to have digital as the technology, and then we have Web3 as the record-keeping layer, and then we have probabilistic symbolic models. So this is basically programs as the layer where we currently have contracts and accounts. And then instead of the lawyers and the accountants translating human text into code, we'll have LLMs and generative AI. And so I think that will allow us to create a decentralized, accountable, and transparent system for where we're going. But it's almost as hard to imagine now as it was for Mesopotamians to imagine our society today.
No, can I say, I'm trying to process this explanation. Today, we have an internet, largely decentralized. Of course, government can shut it off if they want. they can control information. But we can largely say, I can send an email to you, which goes through the continent to reach you in a second, and there is no an account keeping or record keeping, which is keeping track of that whole process. Tomorrow, I can put money into my internet. It can go through wherever it goes through and reach you without an accountant keeping an account of it. I think that's the Web3 layer you are talking.
Yeah, and I would say that was the Bitcoin layer,
Yeah.
but now with Ethereum and other things, I can also transparently make obligations and contracts. So, for instance, if
That is on top of that.
yeah, it's right next to it. And that's why I think it's more than just cryptocurrency, why we say Web3 is, so if I said, if you give me money, I will give you the keys to this house, and I put that in a smart contract, you can look at the smart contract and be certain that if you insert the money, the key will come out like a vending machine.
Okay.
And this doesn't need a lawyer or a bank or a policeman. It's written in code. And I think this is the simple version, but if you imagine that a company is just a bundle of accounts, the whole company could be on the blockchain and be publicly visible, publicly auditable.
Sure. Now, DK, before we go, AI as a layer on top of Web3, when I was with Ravi in his speech last 1 week, it's hard to do speech. And one thing I discovered, AI is actually a 50-year-old solution. And the AI as a technology has evolved from a machine learning to deep learning to large language models, now the Gen AI thing. Just walk us through, from a tech stack perspective, how all of us should process AI, because I don't think we should use AI as a single technology stack.
Yeah, so I was thinking about this. So if I look at from the underpinning concepts that go behind AI, so if you think about first is computer science, right, and then maths, surprisingly psychology, linguistics, and to some extent natural language, right? So these are the things that kind of come together and create AI. And if I look at then the components of AI, there are things like machine learning, right? Where you sort of get the machine to do things without explicitly writing code. It's a very important aspect of the overall AI. Then the third thing is, how do you represent concepts? This is something which I spent a lot of time a few months ago when a set of my classmates from college asked me to explain AI and large language models. And I read this paper from Google. There's a guy called Vaswani who wrote "Attention is Everything," right? Yes. It's a very, very fascinating paper. And where essentially you sort of representing everything as a vector, where in multiple dimensions. For example, the latest GPT-4 has trillions of parameters. And you essentially represent a concept with multiple sort of dimensions. And so that's a very important element of this whole thing, which then leads to figuring out how things are closely related or very different from each other. So that's one aspect. Then you think about all the robotics, which sort of, you've done a lot of stuff around machine learning, you've done things around large language models, and you have figured out natural language processing. And now you've figured, okay, what do you need to do using AI? You actually go and execute something, and where there are things like APIs and robotics come in. So if you put all this together, you are saying something, so you have natural language processing, understanding what you need to do. Then there is machine learning models which are helping understand the intent and the associated entities involved in that transaction. Then you have sort of generative AI-based large language models figuring out how do you go towards the entire objective of getting all that information. I'll give you an example. A pizza buying model, right? You want to buy pizza. Typically what happens when you buy a pizza? You need the topping, you need the sort of medium, small, or big pizza, and you say, okay, is there a discount applicable? And these are type of things, right? So today it's possible that you can define these rules, like act as a pizza order taker, and basically enable a process execution for me, which is a pizza order taker, right? So a large language model will generate out a dialogue automatically, which will say, okay, ask for the toppings, ask for the thickness of the pizza, ask for whether there's discount or not, and then I've got all this data associated with this interaction. Now you have to make sure that it avoids hallucinations. So if you're ordering a pizza for Pizza Hut, you know that Pizza Hut doesn't offer, let's say, large pizza, just maybe as a rule, right? Or it doesn't offer a discount, right? So you have to constrain it, right? And then after all that is done, you have to then execute. And execution means collecting a payment, updating systems of record. So when you think about the entire transaction, it's about like machine learning, NLP, all this large language models, and then the actual robotics or API execution. That's how I think of it as the entire ecosystem. These are the elements.
So DK, before you go to LLM, because I was trying to separate this concept.
Mm-hmm.
When machine learning came, the concept was very simple. You take large amount of data, create patterns.
Yes.
Okay? So you can create behavioral pattern. Then came deep learning. Complex data, multiple data set, different data source. You run this algorithm, it creates almost like a brain-like multiple connector, neural networks. Then comes the LLM. Can you explain how the difference between A, B, and C?
Yeah. So the machine learning, as you said, is probabilistic models, right? So basically, you have sort of written multiple ways of sort of predicting, like either it's a classification problem, or a sort of like creating a score type of problem, right? So those were machine learning models. Now from there, then came deep learning models, where basically you are looking at the same data from different ways. So let's say you like a picture and you see it like, take out the color and just sort of say, okay, different aspects of the picture, what is it, how dark is it and all that. Then you sort of look at a different lens and say, how is the contouring and smoothness and all. So apply all of them together at the same time, and then you sort of figure, okay, this is a dog, or this is an apple, or this is a fruit, right? So those type of things were coming to the deep learning model.
So multiple attributes, sorry. No, you can come in.
Yeah, so I think it's important to remember, though, that in the 90s, before neural nets became, so neural nets really took off, I think, in the ImageNet moment around 2013, when they showed that you can use pattern recognition neural nets. But before that, with probabilistic symbolic models, you don't need lots of data and you don't need lots of compute. The mathematics is hard and it's been difficult. But I think now when we're looking at constraining and things like that, we actually need code that isn't hallucinating, that's structured.
Yes.
And I think there are a lot of probabilistic modeling programming languages, and there's a lot of interesting work at MIT right now in this, that are Bayesian. So because like when humans learn, when a little child is watching somebody, after 2 or 3 times, they kind of know what's going on, because humans have symbolic models that are modular. So if you know physics and you see an object you've never seen before, you can kind of infer what it's going to do based on what you already know. With neural nets, you don't do that. You have to reprogram the whole thing with a whole new data set. Like, a lot of the games that the neural net guys show, the neural net has learned how to play it, like AlphaGo. But if you change the board size by 1 unit, AlphaGo, you have to train it all again, whereas a human could kind of guess.
Intuitively guess it.
With probabilistic models, you can do that.
So let's stop here. Yeah. So we got machine learning clear. Process a lot of data, create a pattern. As DK explained, in the deep learning, multiple data,
looking at it from different views,
different angle, create a brain-like.
Yeah, correct. Yeah.
But I guess I could just argue it's not brain-like.
Okay.
The human brain is actually symbolic and probabilistic.
So brain is better than. So
that's why the brain doesn't need
filters. Just say looking at it from different filters. Looking at it from different filters and then trying.
Okay, let's say partial brain capability. I can look at the same object in different data sets, create a sense. This looks like an AlphaGo game. That's deep learning.
No. So human intuition is a probabilistic model. So this is the mistake, because you call it neural nets.
Okay,
you think it's like the brain.
Out.
It doesn't have anything to do with your brain. It's very unlikely our brain has like a neural network thing. A neural network is a statistical model.
I see.
Where it's more like pattern recognition by a machine.
I see.
You see, and the human brain is actually much better than that. The human brain works with, because you only have like 1 light bulb worth of energy, and you have very little data, and you can make all kinds of inferences. Yes. And even if you don't have much data, you kind of know how likely you are to be right, and you have a probabilistic model. You kind of guess this is likely so.
I agree.
With neural nets, they don't have it like when ChatGPT hallucinates, it hallucinates without any sense that it's hallucinating because it's just kind of guessing based on a statistical model. So I guess all I'm saying is that I think that neural nets and LLMs and things have been very popular because it was a way to just throw machine power and data, and somehow it worked. But I think that what we're going to see eventually is that more symbolic models where we actually understand how it's working is going to be the way that we scale up next. Okay. And then the way that we have safety. I think you have to start transitioning.
Yeah. So right now, as you said, it's all still probabilistic, right? So deep learning, you came to the second level. The third level is this large language model. So large language models is you ingested a huge amount of corpus of data. And as I said, represented in that vector space that I talked about. And that now the model is created like you sort of have this transformer. You take take information and you encode it and transform into an action into an output. And that's GPT-4, that's BARD, that's Gemini, and all that. Now, what that model does is basically it has represented all of this information through these trillions of parameters. And now you need to train this model to do certain sets of things. So let's take a simple example. You have now this GPT-4 model, and you want to do summarization of a bunch of lines of text into one sort of succinct summary. What you do is you create input data, which is a bunch of sample data sets, which have got this inputs, and then you say this is a summary. So the model is now seeing, I got this set of data, and this is the output. Now it will try to understand how the two got related in that space. And then you sort of do, okay, so then the initial model then becomes trained to do that task. Now you subject it to testing and with responsive learning with human feedback, where that's what OpenAI did. They employed thousands and thousands of people around the world to annotate that data and to come back and say, okay, this was right or this was wrong. That made the model better. What OpenAI did was to use those many people to then do those things which GPT does very well, like in terms of classification, summarization, and things like that.
But still that is still
probabilistic. It's still, so it can still hallucinate.
Yeah, still.
So what we do at Kore to sort of say, okay, how do I practically use it? So I have to put constraints on top of that. So for example, we'll say, okay, act as a pizza maker, and you sort of say, what are the choices of pizza? Now using the corpus of data that's available, you say, I can give you a large pizza, I can give you a medium pizza, I can give you a pan pizza.
Sure.
The constraint you put is that I only offer 2 pizzas. So now I say, subject to the constraint that there are only 2 pizzas available. So that's how we're trying to reduce the hallucination. And hallucination can be further reduced by reducing the context. Because as you keep reducing the context, the hallucination reduces more.
Can I push back? Because I'm taking some hint from Joichi's point. Actually, hallucination is not bad. Human being hallucinate, but without the data set available, which is almost correct, right? Why hallucination?
Hallucination is not bad if you're not doing something which is like money transfer. Hallucination is not bad if you're not doing, if you're writing poetry, hallucination is okay. But if you're doing a financial transaction
without a context.
Yeah, you cannot hallucinate when you're doing a financial transaction.
And just to sort of clarify the terms, so I think what we're talking about in your pizza example is you have symbolic constraints above.
Yes.
But also, you don't want an LLM to do the payment.
Yeah.
So you use symbolic tools. So even with
Correct.
GPT right now, if you ask a math problem, it's going to write Python code and execute symbolic code.
Correct.
And where I think the argument is, at least for me, is that I think the LLM people think that 90% of the value will be the LLM in the middle with constraints and subroutines symbolically. The symbolic probabilistic people believe that eventually most of the LLM work will be done by machine-generated symbolic code, and that only the language translation part really remains for the LLMs. And I think it'll be interesting to see, because even all the big LLM companies realize that LLMs can't sit and reason. They just do transformation.
Okay.
And so they're starting to write all this code that isn't really neural nets.
Yeah, that's what we are very successful, or we think we have a space for ourselves, because we think LLMs are really just a foundational commodity. When you actually come to executing the transaction, you need to do a lot more. And that they are very deterministic things.
Okay.
Like making a payment, like issuing a credit card.
So now, connect the dots. You said we have a new Web3. We spoke about AI on top. Why does that matter?
So Web3 makes all the data available.
Okay.
But unless you can understand it, unless you can ask it questions, and unless you can control it, it doesn't help because it's just increased complexity without increasing manageability. And like if you look at SDGs, right? So SDGs, if you could do automatic OCR, if you could understand what was going on, and then if you could have natural language interface so that if I want to be able to say, none of my pension money should go into the balance sheet or equity of any company whose values I don't agree with. Look at my media and my email to figure out what my values are. Look at the company, what they're saying and what they're doing to figure out what their values are, and never allow my assets to underwrite anything I don't like. And by the way, if I go into a store, make sure that any product from a company that does anything that I feel is unfavorable, I can't buy. And then suddenly imagine if you could do that, right? If you had the record keeping and the AI, you could do that. Then what would happen is right now what we have this very handwritten way of you wear an SDG badge, you do an audit of your company, and you announce it and all this stuff. But imagine if no one bought anything from companies they didn't agree with, if no one invested in things with companies that they didn't agree with, and somehow we were able to have a global conversation about values, the whole corporate governance idea would turn kind of inside out, right? And I think that the blockchain promises that, but without AI, there's no way to ask a question. And that's why you have all this.
So you're asking question to the what? To the software which is running.
So I think what will end up in the world is a network of probabilistic models.
So Joichi, explain in a simple way. How do I see this? I have to ask question to whom?
So let me give an example. So I was thinking of this thing yesterday, that you can actually create. Why did this issue happen of people who are in a particular school drinking, let's say, water, and they were subject to lead poisoning? I'm just a very hypothetical example, right? Now, if let's say you had distributed, data, distributed financial data, and you were sort of publishing the information around the students, blood records or whatever, and that was getting, into the school's, let's say, ledger, if you will, right? That this is the health of my students. And now you have AI sitting on top of that, which is monitoring patterns, which says, hey, I'm seeing something crazy here, that these guys' lead levels are going up. And that's a trigger that goes out, and that tells, oh, shoot, maybe is there something wrong here, that they have been drinking water which is from
but
pipes.
Who is controlling this?
No, but that's the AI running on top of that distributed data.
Who owns that AI?
That could be the school be running that interrogatory AI on top of that.
If it's his Web3 expression.
No. So I think Web3 is like the internet. It allows all these models to talk to each other, and it manages identity and it manages access control. And what the government and other people have to do is they have to say, okay, so instead of a ledger in a school, all of your data will be in a model. And if you're a parent, if you're the government, you're going to say, okay, I want my model to be able to ask questions to your model. Yes. And all of our models in the world should be connected to each other. And then we should always be running this query, which is basically something like, if there's any scenario in which there could be a bank collapse, that scenario higher than 1% probability, make sure that it's disclosed to the government. And that should be a thing that could operate against the models by anyone.
So Joichi, you used a word called government, but Web3 people hate governments.
So, but the people who created the internet also, didn't envision us using it for streaming and entertainment. I mean, I think that the decentralizing and the hate of governments allowed a very unlikely architecture to be created. But it turns out this architecture is going to be useful for everyone, and I think it will be used by the government. Yeah.
Oh, okay.
No, Mohanty, take my own example. If I got, so go ahead.
Yeah, go ahead.
No, let's say I get my blockchain store of my data coming from wherever I go, they distribute it to me, and that belongs to me now.
Sure.
I can run, on my data, things which tell me whether, what should I do tomorrow? I mean, look like I'm not doing, I didn't do enough of an exercise. I should go and exercise and see how that will reflect on my, on my health immediately, right? So how did I get this data in my data store? I have now got the data distributed from my earlier I would have to go to Mayo Clinic's record and pull that information. I'm not doing that now. As soon as I get those tests done, that gets pushed to my blockchain data store. And I'm able to query on that using AI. I can search on that using AI. I can take actions on that using AI.
I think that's the key thing is I think if you put a database somewhere, somebody controls it. But if it's on the blockchain, you can have access control to cryptographic keys and things like that, but it's not owned by anyone. It's owned by everyone.
So every individual has some kind of data set which they are proliferating on the network, and that is affecting the models.
Yeah, and you will have access control using cryptographic keys.
Okay.
But the idea that, because with a database, somebody owns the machine.
Sure.
And that person inherently has a lot of control.
Correct.
Right? With blockchain, no one owns the machine. You can have access to the keys, but it puts the control of the data at a different layer.
Sure.
That's easier for stakeholders to manage.
So now we have almost 4 minutes, little more than 4 minutes, no, less than 4 minutes. I have a very government type question because I'm from the government, right? If you look at history of AI, every 10 years from 1950, the technology went here, government intervened, it went down. Then came the next technology, government intervened, it went down. What was really happening that when government intervenes, they actually take the budget out. So less funding to these ideas. But this time is interesting. The amount of funding accessed for this technology is unprecedented. Sam Altman is going around asking for $7 trillion capital. So funding is not going to stop the progress of the technology. But every regulator, almost I think 60 or 70 regulators have come across with some kind of regulatory framework to control AI. What does it mean to you?
It is, okay, for me, so as we are implementing our use cases, so the thing which we are currently working on, like generative AI is extremely sexy and extremely good, but even very simple thing, if you go to a bank, and let's take a very simple example. Today, when you call a bank's IVR, we today record all types of text that is to be spoken out. It's a very painful, tedious process. And using generative AI, I can generate really good content, and it can be, mentioned on the spot, and it can be generated on the spot based on the consumer sentiment, the context, and things like that. However, the lawyers and the regulators will say disclaimers, this and that. How do you make sure that all that is correct? So we have to work together and figure out a framework with which we can confirm that it is not going to hallucinate in the context that we are talking about, so that we can replace this antiquated architecture of, think about like multiple ways of saying things in different contexts, which is written out in a typical IVR tree, by generative AI-based speech generator, which is subject to constraint and does not hallucinate. So my problem is, how do I work with governments and regulatory entities to regulate that and make sure that it comes out?
But the regulation is far more than the narrow scope, because the regulation is from data privacy to IP protection,
Yes,
to fairness, ethics, accountability. Human being is not fair to start with.
toxicity, bias, all that stuff.
So we all have bias.
Yeah.
So how does this regulatory framework going to?
Well, so I personally think it's very important to have a global conversation about what our values are and try to deploy this as regulation. But I think the way I think about it is, the internet was very difficult for the media because the media itself was kind of targeted, right? I mean, media transformed, so it was hard to write objectively about the internet. And I think the thing that's complicated and difficult about the combination of AI and Web3 is it's fundamentally changing the nature of law and accounting, which is the core of regulation. So I think that, I think it's important to, and that was kind of my point with this chart.
Yeah.
Like, I think the idea of nation states or the idea of handwritten regulatory policies is going to make way for some like machine code, like executable compliance and regulations.
So one of the node in the network will be a regulator.
Yeah.
Now we have a minute time. Let me ask you the last government question. Out of 7 billion people, only 30 or 50 million people know programming. So there's always a concentration risk on the whole digital thing around us. Now with AI, it is becoming less than 1 million people, perhaps more or less, who understand AI. Now the world is going to be run by few people. Is there a huge concentration risk in our society? I mean, I don't know why most of the systems run, because some programmer in India knows all these things.
I think there's two sides to this. So one is, with the natural language interface, more people can understand AI than before. because
Of
millions
course.
of people can talk to
We get
it.
more addicted.
Yeah.
But
But I think you can sort of program ChatGPT, and I think programming will, in general, become easier. And I think this is my guess, and I'm in the minority, but I think that we'll figure out how to do structured probabilistic models that aren't as expensive and don't take as much data.
there's only one Joichi will understand what goes below.
So I think that it will be a problem, but I also think that this idea of super concentrated AI power may change if we can pivot away from these neural nets, because they're very machine insensitive.
But why would you not take the opportunity there that, for example, using generative AI, and you can actually document these things. They can become self-documenting.
I fully buy this.
And that can become available to a lot more people.
My worry is that all the goodness of heart is still controlled by a few people. So we have an unprecedented level of concentration due to AI now. Already we had a concentration risk due to digital transformation, all the software coming in. Now we are coming to a minority of people like Sam Altman, Joichi, who will control the world.
Not me, but yes, I agree.
Yeah, somebody like you.
But I agree it's a problem we should address, and it's something that...
How?
I think we need to get more transparency. So I'm not against regulation. I think it's important. I think it has to be smart, technically informed regulation, and I think that's the problem, is that it's incentivizing technical people to work for a government is hard, but it's not impossible. Like the AI Safety Institute just hired one of the senior people from one of these foundation models, and I think younger people, you can find many that actually want to...
So more training, more education.
More training, more skilling, and I would say, why would governments not invest in creating some of this? I mean, I've talked strongly about this fact at another forum where, Sam Altman said, India can never create an LLM. Why not? I mean, if you look at a nation level, why can't it be created?
When I just heard we don't need LLM can be commodity. It can be self-created.
Eventually, now, yeah.
But you need the compute, you need the data, you need still all that rigor to create that, right?
We're out of time. I know we can spend the whole day talking about AI, still don't understand this. But I think I have some optimism from the discussion. We definitely take huge advantage of, as a society, to the AI to be helping us to understand the system, the processes, the outcomes in a more efficient way. But I think we need more DK Sharma, more Joichi to be in control of our destiny. With that expectation, thanks for joining me. And
thank you.
And a great conversation.
Thank you.